In this video, we're going to take this limit that we know is actually the very first limit we met in this class. There's also a Khan Academy video posted in this week's lessons that help us understand it better. We're going to use this limit to evaluate other limits that kind of look like it but have some things that aren't quite right. One observation I want to make right away is that if this limit is true, then this limit is also true, because the reciprocal of 1 is 1. So if I see a sine theta over theta, theta is going to 0, I know it's 1. Also, if I flip it upside down, I know that will still be true. So when I look at this limit, it kind of reminds me of this one, but it's not a theta over theta. It's a 2t over t. To be equal to 1, I need the argument, the thing on the inside of the trig function, to identically match what's on the bottom. So I'm going to change this limit just a little bit. I'm going to be sneaky. One of the things I can always do to a fraction is do the same thing to the top and bottom. So I'm going to multiply the top by 2 and the bottom by 2. Right, because this would cancel out and give me back that. But what I can say now is the constant multiple rule says that 2 could come out front. And now I have sine of 2t over 2t. Something over exactly the same something. This limit is now in this format. And so now I know this limit goes to 1. So 2 times 1 is 2. Looking at this problem, instead of a 5t, I want to say 3t. So what I'm going to do first is use that constant multiple rule to pull the 5 out front. And now I'm going to use that same line of thinking. Oop, that's a 3t in there. But I still can use that same line of thinking. I want this to say 3t on top, which means I need to multiply a 3 right there. But the constant multiple rule says I could go on and think about factoring that out front. 3 on the top, 3 on the bottom, they still cancel. The limit as t goes to 0 of a theta over sine theta is equal to 1. So here I get 5 over 3. So those two problems kind of have the same feel. I manipulate my fraction just a little bit to be able to use one of these expressions. I have 2 more examples. These ones are just a little more interesting. So right away I notice this one doesn't have a sine or a cosine, so I'm going to rewrite my trig expressions first. I know that tangent x is sine over cosine. And I know that secant is a 1 over cosine. All right, so let's rewrite this. Just rewriting this, I have a fraction times a fraction divided by a fraction. I'm just going to write that as a times a 1 over 3x. Now, I'm going to continue just rearranging things. It doesn't matter what order I write things in as long as I have the same things on the top and the same things on the bottom. I'm using the commutative property of multiplication. Oh, and I've made a cardinal sin. I made a mistake, a horrible one. I left my limit out. We can't do that. I need to remember I'm taking a limit the whole way down. The only time I get to remove the limit is when I've actually evaluated it. All right, well, I'm going to use my product rule. The limit as x approaches 0 of 1 over cosine of 2x is 1, because the cosine of 0 is 1. Same thing here. So that leaves me the limit as x approaches 0 of 1/3 times sine x over x. The limit as x approaches 0 of sine x over x is 1. 1 times 1/3 is 1/3. All right, so now I have to work on this one, and this is the one where I have to be very creative. The first thing I'm going to do is imagine this as 2 fractions being multiplied together. To be able to use the limit I want, I would need this to say 2x on the bottom and this one to say 5x on the top. And that seems very problematic at first, but one nice thing that happens I can actually imagine multiplying this by x over x, because x over x is 1. I'm not changing my fraction. And I can put those x's wherever they are convenient for me. So I'm going to write 1x here and the other here. One's on the top, one's on the bottom. I lost a 5. So I haven't changed my expression. Those x's would cancel out. But I need this one to be a 5x. I need this one to be a 2x. Well, I've definitely changed my fraction now. I multiplied the top by 5 and multiplied the bottom by 2. So I'm going to imagine a 2 on the top to cancel with that and a 5 on the bottom. And I could imagine writing that out front because of the constant multiple rule. But now as x goes to 0, this goes to 1, this goes to 1. 1 times 1 times 2/5 is 2/5. All right, that's it for now.